so this is our second lesson in our second unit, and this is where we're going to get into actually talking about finding limits. Okay, so like I mentioned before, reading this lesson or this section in the textbook is going to help your understanding, as well as reading those pages that I posted from Calculus for Dummies is going to help you understand kind of a lot of the stuff that we're talking about here. Because again, I focus on the putting slides in here for examples and work, whereas there's some good stuff that you should be reading in those other two resources. Okay, so we're going to talk about finding the limit, using tables to help us estimate the limit, or finding out when the limit does not exist, looking at graphs to help us find limits, looking at one-sided limits, and explaining the relationship between one-sided and two-sided limits. And then eventually the last part is looking at infinite limits that lead to stuff we talked in the past in algebra called a vertical asymptote. Okay, so this whole first slide, there's nothing to write here. But again, this is where you're going to be doing the reading about looking at what happens with these three different functions. All right, so they're put in A, B, and C here in the figure 2.12. And essentially you can look at, as you're moving from the left and to the right, as you approach x equals 2, right? So if you just focus on the values or the value x equals 2, you can see that we have three completely different things happening here. On this one, right, as we're approaching it from the left and the right, we're approaching that y value of 4. All right, so even though there's an open circle there, that the function does not have a value that works for x equals 2, right? It makes the denominator 0. We would have a limit that does exist at x equals 2 in part A. In part B, this is where as you're coming to the left and then as you're coming from the right, you'll notice we're approaching two different numbers. So we'll talk more about this later on the lesson, where if you have looking at the limits, the limit of a function as x approaches a number from the left and from the right, and they don't match, this is where the limit of that function as x approaches that number would be does not exist, or DNE. Again, we'll talk about this a lot more in detail soon. And then finally, the last part C, is at the end of our lesson, we're looking at what happens when, as you approach it from the left and from the right, you're approaching, right, you're going up forever, so infinite values or infinity. And this is what's going to lead us to describing something as a vertical asymptote, okay? All right, so let's get into using a table of values to help us figure out potential limits here. So I'm going to start with x, and then here's where I'm going to put our function sine of x over x. Same thing here. All right, and I'm going to approach this. All right, we're talking about the limit of x approaching 0 from the left of 0 and from the right of 0. So negative 0.1, negative 0.01. So I'm getting closer and closer to 0. All right, same thing on the right. Getting closer and closer to 0. All right, I'm going to use Desmos to plug this in, and to save time and really just like lines on Desmos is when I get a number and write it in my table, I'm just going to use that same line in Desmos and replace it with a different x. All right. So let's go to Desmos. All right, I'm plugging in the sine of x over x, and I'm plugging in negative 0.01. Sine of negative 0.01 over negative 0.1. All right, so I'm going to write down 0.998, okay? I'm going to do the same thing for the next three. So I'm just going to change this, like I said, to make it a little easier. 0.999, 0.999, lots of nines. And you could write down, more nines here. But what you're going to find out is as I plug in the other ones, I'll confirm for you that we get essentially just 0.9 repeating. It's not going to be 0.9 repeating, right? We're rounding. If I add some zeros in here, getting closer and closer to 0, you're going to see that the number of nines is going to increase, okay? So essentially, from the left side, you should see that we're approaching a value of positive 1. Now let's try from the right side of 0. So let's plug in 0.1. Okay, so that's going to start out with 0.998 again. And same thing's going to happen as I plug in more zeros or get closer and closer to 0. You're going to see that my y value is approaching 1 again. So let's do that so you can see it. So let's add in a 0. All right, so getting closer and closer to 1. And the last one here. Excellent, okay? So what we would say in terms of this table is we would say the limit, right, because this also approaches 1. And if they both approach 1, we're going to say the limit as x approaches 0 of the sine of x over x equals 1. Now I'm just going to show you, take a moment to show you what this looks like on the graph. So if I were to graph sine of x over x, all right, so I'm going to graph sine of x over x. And kind of zoom in. We get from the left and right of 0. You can see if I trace it, see how we're getting closer and closer to 0. My y values are getting closer and closer to 1. But we never actually get to 1. We'll go this way too. Because you'll notice at 0, we're undefined, right? Divided by 0, we can't do it. So even though the function does not exist or does not have a value that when you plug in 0, it doesn't give you something, it's undefined there, we still have a limit. So that's one of those interesting things that even if the function is undefined at that value for x, you could still have a limit. Okay, let's do another table. This time approaching 4. So I have x, and this is the square root of x minus 2 over x minus 4. And even as you're writing this, you can take a look at this function, and you'll notice that if I were to plug in x, we would get 0 in the denominator again. So same idea. From the left is going to be 3.9 this time. So 3.99, lots of 9s. And then from the right, 4.1, and getting closer, too many zeros, getting closer to 4. There we go. All right, so let's plug in some numbers and see what happens as we approach 4 from the left and from the right. So we have the square root of 4 minus 2 over, oh, I'm typing in 4, it's 3.9, my bad. Put in parentheses, over 3.9 minus 4. Confirm that's the right stuff. Okay. And so we get 0.2516. Okay, let's see what happens when we plug in a number closer to 4, 3.99. Again, just to save time, I'm going to type it in here. 0.2502. Okay, I think you probably know where we're heading here. Another couple of 9s. 0.2500. What happens with that last one? Also 0.2500. So what we're approaching, right, as we get closer and closer to 4, is we're approaching 0.25. Let's see what happens when we go from the right of 4. So starting at 4.1 and getting closer to 4. Okay, so it starts at 0.2485. Okay, let's try adding a 0 in. Same thing here. 0.2498. Okay, so you can kind of see where we're going. And let's try adding these last two here. So another 0. Another 0. 0.2499. And finally, 0.2499. So again, from, oops, sorry about that. Where did it go? Oh my goodness. Whoa. 0.2499 for both of these. Okay? So essentially, what we're saying is from the right side, it also approaches 0.25. So we would say again, the limit as x approaches 4 of the square root of x minus 2 over x minus 4 equals 0.25. You could, again, confirm on your graph. All right, so now let's actually use a graph to help us find the limit here. All right, so it says, evaluate the limit as x approaches -1 of this function g of x. All right, so what I like to do is, if you look at it from the left and from the right, as x approaches -1, you'll notice that we're approaching this y value of 1, 2, and 3. So what I want you to know or take away from this slide is that even though g of -1 is actually 4, right, the point up here, we actually can find the limit as x approaches -1, which is different than the value of -1 when you plug it into the function. So that's something that is new and you may have never seen before or haven't seen before, which is okay, but just showing you that this is a possibility if this occurs in your function. Okay, let's do another table of values. Let me erase all this nonsense, there we go, that I have here. All right, we're going to use x and the sine of 1 over x. And we're going to go from the left of 0, so 0.1, negative 0.01, get closer and closer to 0 here. Getting really close. One more. All right, and then from the right side, all right, can I fit it in here? 3, 4, 5. Good. Awesome. All right, so let's use Desmos. See what happens as we plug in numbers from the left and right of 0 of sine of 1 over x. So we have sine of 1 over negative 0.1. You get 0.544. All right, I'm going to change it to negative 0.01, 0.506. Oh my goodness, look at these numbers. Okay, let's go back to the first one. 0.544. Okay. Add in that 0, we get 0.506. Okay. Another one. Negative 0.827. Huh, that's interesting. Positive 3.306. So this doesn't really seem to be approaching anything. I mean, we're going from positive y values and we have a negative y value. Let's keep going, almost there. Negative 0.036. Is that right? Yes. And then 0.350 at the end. So that really didn't help me. We were kind of all over the place. Let's try what happens when I move from the right of 0. All right, so essentially do the same thing, but with a positive. So negative 0.544. One more 0. Negative 0.506. Interesting. Looks like it's just the opposite of the ones on the left side of it, of the table. Let's see what happens with this. Then I can make that conclusion. Positive 0.827. Okay. So I'm just going to copy then over the same thing I have from the other side of the table, but make them opposites. And what you should notice is we're not approaching any number. So this is one of those where the limit as x approaches 0 of the sine of 1 over x does not exist. All right, DNE stands for does not exist. And I'll show you briefly that graph of the sine of 1 over x so you can see. So if I were to plot the sine of 1 over x, and you zoom in, again, we're zooming in towards 0, it's hard to even tell what's happening there, but it's actually oscillating back and forth rapidly. So your y value is going up and down, up and down, up and down. So this never approaches a number, so that's why the limit does not exist.